In this video, I'm going to talk about static routing. I want to show you how you can configure static routing with three methods. I want to first talk about the need to static routing, and after that we can talk about the configuration methods, and after that we have a practice, we have a scenario, and we can configure it and learning more about the static routing. By default, every router only knows its connected networks. For example, assume this scenario. In this scenario we have R1, R2, R3, and R4, and also four LANs. The first LAN is the LAN between router 1 and VPC1. The second LAN is between router 2 and VPC2. The third between router 3 and VPC3, and fourth between router 4 and VPC4. And as you can see, R1 connected to router 2, router 3, and router 4 with serial links or serial interfaces. By default, R1 only knows its connected interfaces or its connected networks. For example, if you check the routing table of R1 with this command, you know that if we want to check the routing table, we can use the show IP route command. If you check the show IP route, you will see four connected networks: 10.0.10/24, 10.1.20/24, 10.1.30/24, and 10.1.40/24 in the routing table of the router 1. Okay, and because of that, R1 can't send traffic to, for example, 10.0.20/24 network, or 10.0.30/24, and then 10.0.40/24, because R1 doesn't have these subnets in its routing table. For example, assume that VPC1 sends the traffic to router 1 destined to 10.0.20/24, or the 10.0.2, for example, 10, the IP address of the VPC2. R1 should drop that traffic. How we can learn in R1 that, for example, if R1 receive a traffic for 10.0.20/24 network, it should forward the traffic to router 2. We have two methods. In routing, we have two methods to completing the routing table. The first method is static routing, and the second method is dynamic routing. Static routing means administrator should itself configure the routes. For example, I want to say R1, hey R1, if you receive a traffic for 10.0.20, please send that traffic, please forward that traffic over the serial 10 interface, for example. This is the static routing or manual routing. But in dynamic routing, we are using some protocols. We call them routing protocols. Okay, and with routing protocols, every router can learn the best path to a destination. I will talk about the dynamic routing and routing protocols in the future videos. In this scenario, in this video only, I want to talk about the static routing and how we can use static routing for completing the routing tables. Very good. But for a start of our scenario, first we should configure this scenario. After that, we can talk about the detail of the static routing. You know that here we have R1, and first we should configure the R1. This is the configuration of R1, for example, en conft. I want to use the notepad file because it's easier and it's faster. Then we have four interfaces: interface ETH00, IP address. The IP address of the ETH00 is the 10.0.1.255.255.255.0, and then enabling this interface. Look at here, because the link between router 1 and router 2, these links, the serial 10 between router 1 and router 2, I'm using 10.1.2, means between router 1 and router 2, and the serial 11 10.1.3 means this link is between router 1 and router 3, and also this link 10.1.4. But because the ETH00 is our LAN interface, I'm using the 10.0.1, means only between router 1 and a LAN, not another router. So easy. Interface ETH0 10.0.1.255.255.255.0. Then you can copy this configuration, for example, for a other three interfaces. The first interface is serial 0 interface, serial 1 0 this interface, and the second is serial 1 1, and finally serial 1 2. That's it. And then you can change the IP addresses 10 1 2 1 because it's interface of router 1. I'm using 10 1 2 1. This means that this link between router 1 and 2 and on the router 1. The serial 1 1's IP address is 10 1 3 1. That's it. And serial 1 2 is 10, for example, 1 4 1. So easy. Okay. And then you can go to the router 2. In router 2, we need also in router 1, you can change the host name. For example, host name, the R1. Okay, so easy. Now we can go to router 2. In router 2, I need only two interfaces. Because of that, we can copy this part of the configuration of the R1 and copy this for router 2. This is for router 2 and also router 3 and also router 4. So easy. Okay, then first we should configure router 2. This is the router 2's configuration, and then this is the router 3's configuration, and finally router 4 configuration. Let me to start with router 2. In router 2, first we should change the host name. Host name is router 2. Interface ETH00's IP address is 10.0.2.2. Why 2? Because this link, this interface is reside in the router 2. Because of that, I'm using the 10.0.2 for subnet and then 2 for the host ID of the IP address. The interface serial 10, this interface has IP address of 10.1.2.2. So easy. In router 3, again, changing the host name to hostname R3. Interface ETH00's IP address is 10.0.3.3 and serial 10 is 10.1.3.1. 10.1.3.3. Okay, 10.1.3.3. That's it. In router 4, host name is router 4 and also the IP address of ETH00 is 10.0.4.4. Okay. In serial 10, 10.1.4.4. So easy. Okay. This is the configuration, the initial configuration of our scenario. And first we should copy this configuration into the CLI. After that, we can check the result. First, R1's configuration. And this is the CLI. Let me copy this configuration into the R1 CLI. This is empty. Okay. And now you can see the configuration is applied to R1. Then R2, this is the R2's configuration. Again, we should copy the configuration to R2 CLI. This is the R2 CLI, very good. And then R3, this is the configuration of the R3. Then in R3, I want to copy this configuration. And finally, we should copy the configuration of R4 into the R4 CLI. That's it. Now, we configured the routers and also we have some PCs. You can configure the PCs also. Look at here. This is the VPC in EVNG. You can configure these devices easily. How? Let me to show you. The VPC1, for example, the VPC1, as you can see, is connected to the router 1. Okay. I'm using the 0.10 for the host ID of every VPC. You can configure every VPC with this command, IP 10.0.1.10, and then you can use 24. This is the CIDR notation of mask or /24. And finally, you should give to VPC1 the default gateway. The first IP address is the device IP address. The second number is the subnet mask. And after that, we should use the default gateway 10.0.1.1. That's it. This is the configuration of the VPC1. Then you can use this configuration and changing to VPC2, VPC3, and VPC4. VPC2, VPC3, and VPC4. The VPC2's configuration is IP 10.0.2.10. The gateway is 10.0.2.2. And after that, for VPC3, the IP is 10.0.3.10, for example, and gateway is 10.0.3.3, and for VPC4 is 10.0.4.10, and the gateway is 10.0.4.4. Okay, so easy. Let me to copy this configuration also. First, VPC1, copy the configuration of VPC1. This is the VPC1, and then the next device is the